All right, well, we made it to Wednesday. Hopefully, you had a good Labor Day. Do anything fun? Nothing? Jazz Fest. Okay, how was that? Nice. I heard that was good. Anyone else do anything fun? Hmm? Yeah. It wasn't on Labor Day, but over the weekend before, like the Friday, Saturday, Sunday, there's a gaming convention out in Grand Rapids. They do every year. It's a lot of fun. If you like board games, tabletop games, so a weekend worth of fun. It's really good. All right, so we are moving on now. We're going to finish out chapter two. We got a good start on chapter two. Didn't get through everything, and that's okay. And we'll finish that up, and then we'll talk about the first project assignment for you folks. So that'll be due in 2 weeks from today. And we'll just sort of keep that every 2 week cadence, and it should work pretty well for us. So you'll need a little bit of stuff from the next week, but you can do most of it now or after today. You can get most of it done. And then next Monday, Wednesday, we'll talk about all this branching stuff. That's the last little bits that you need. Generally, you won't need stuff from the later weeks, but if I waited until this week to give projects, it throws everything off on the schedule, and then I would feel bad, like, because then somebody would end up on the midterm, and like, it's okay. So it won't be too bad, I promise. This is it's a relatively soft intro. It's not anything overly complex, but we'll get to that when we get there. Does that sound okay? All right, so hopefully you all found your Zybooks here. Let's see, is this the right one? Yeah, okay. So let me open up Visual Studio, VIS, there we go. I think we got as far as modulo, right? Division and modulus. Did we get that far? Should look at and see how far we got in the code. And then I don't know if anyone got bored enough to go out and look, but out of my GitHub here, there's the CIS150 repo. Come on. This one, CIS150, all 2023. Or it's linked from here, so you don't have to remember. I didn't link it. Oh, goodness. All right. I forgot to add the link. This one here. It's on my website, so if you go to the website link, then you can link here. That's fine. This is the course repository. So all the code examples I do, I'll put out here in the course repository, so you can go find them. And if you ever want to come back and look at them, they'll all just be right here in this section, right? And ideally, I'll name them by chapter or something like that. Sometimes I do week names, and I get confused sometimes. So just shout at me if you like a particular convention. It all should work okay. Yeah, we did modulus. You guys are looking at me like I'm crazy. You just don't remember, right? This is modulus. That's the remainder, right? The integer remainder. Now it's all coming back, right? I know it's been a week. It's okay. All right, so just some basic arithmetic, right? C++ can do arithmetic. Works out okay. So far this has all been with our integers, right? We did a little bit with doubles here. So if you want numbers with decimal places, you probably want a double. There are other types you can use. I'm relatively lazy and I just prefer doubles because it's easy. They take up more space than other ones, but for our purposes in this class, we could care less, right? Because we're not going to do anything at the millions times scale at all. And even at the millions times scale, our computer has tons of memory, right? That's the fast stuff, our random access memory. We got lots, right? It goes from bytes to kilobytes, which is like 1,000 bytes, to megabytes, which is 1,000 kilobytes, which is 1,000,000 bytes, to gigabytes, which is 1,000 megabytes, right? So that's 1,000,000,000 bytes. So at 1,000,000,000 bytes per gigabyte of memory, it's okay if we're using doubles versus floats for what we're doing, right? Because we can have billions of the numbers and still not use up that much memory. Okay. All right. Again, I don't want to use these same examples. I just want to kind of use this as a make sure I'm hitting all the things here. So I'll try not to go into these here because I want you to be able to see it on your own. Is anyone enjoying Zybooks or anyone really hating Zybooks? It's actually a cool platform. What do you think of it? That sounds like a them problem. Yeah, I'm sorry. They've got a support line, or I've got someone I can reach out to if they're not helping you at all. But it's usually like you punch in the code and you get it right away. So yeah. I did some. So there's more labs here than you need to do for chapter 1. So I left a bunch of them hidden because they're just not worth doing all. Right? It's really repetitive at that point. So for chapter 2, I opened up all of them here. And then we get to chapter 3 next week. I'm only going to do some of them. I don't think we need to do this many labs in. Oh, wow. Pardon me a second. I don't think we have to do this many labs in Zybooks in addition to our other labs, but they're good practice. So usually we'll do most of them. After you've done like 3 of them, you look at the next one, you're like, oh. So it's good practice, though, right? It's good practice. And that's the philosophy. The only way to get better at writing code is by writing code. Right? You can listen to me all day long. You can listen to YouTube videos all day long. You can read the textbook all day long. But until you actually write it, you're not going to get much better, right? Is that a question? Sorry. Yeah. So I just added the link here to Canvas. It was also linked off of my website if you cared to go there and check that out. But here's a direct link right to it. So everything I do code-wise, I'll put out here because Canvas is a terrible place to put code, and I will die on that hill. I don't care what other people say. Canvas, code sucks on Canvas because it's not really made for it. You can put files out there, and then you have to download files, and you have to open files, and then because Visual Studio is all project-based, you can't just open a C++ file and run. You have to make a project and put that code into the project, and then you can hit the run. Like, it just sucks. Okay, so I'll just put it all out here. You can make a copy of it with that clone process in GitHub. I don't recommend it because then you have to keep updating it and getting in sync. Most of the time, you just want to go look at it, right? If you want to go look at it and run it, you might just want to copy paste, right? Go find the CPP file, start your own project, and you can copy paste the stuff in. It's not so bad, right? You just grab a couple lines and you go, right? If you're the kind of person who likes the Control A shortcut, it works, which is really cool. It doesn't actually grab the entire page, which is kind of amazing. So they've like overridden the defaults for what that's supposed to do. If you like keyboard shortcuts, I love keyboard shortcuts, but I only know some of them. Control A is for highlight everything. So usually that would give you like everything on the page, but it just gives you the code because GitHub's like, hey, you probably want the code here. You don't care about all this other nonsense, right? So it's pretty handy. All right. So let's keep on going then. We good to keep moving? All right. So we looked at modulus. Yep. Some math functions. There's some cool math functions built in that we don't need to reinvent the wheel for, which is really fun. So to use them, you're going to add another include thing here. And I can never remember what it is, so I'm just going to go copy it out of here. So we're going to include, that's really small, sorry. It's a CMath. So C for C, and then math for math. So include CMath gives us the CMath library of all sorts of cool math functions that we can use. And honestly, I don't remember a lot of them here, but a couple of fun ones, right? Square root, or POW for power, or FABS, which is absolute value, but with an F. There's a reason why. We can probably Google it, right? So why is C++ absolute value have an F? Final? Maybe? What is this? Have an F. No, that's fab or fab. Stack Overflow. What do they say? Huh. I don't know if that makes any sense. Right, I'm confused by it. I don't really know. Because you can't have negative. Negative absolute value of an integer? I'm so confused. All right, C++, fabs versus fab. I'm sorry? Yeah, I think they have it there, but I was trying to see why. Fabs only deals with floating point numbers. And abs is for integers and floating point numbers. Okay. Huh. Okay, so you can't have a floating point number or a double as a result of an absolute value of an integer. That's great. Okay. I'm confused. It's okay. Sometimes you just do things. So if you want, then, right, we can do some math. So we can see out and ask them, enter two numbers, or what's, we take the square root, right? Enter the number to get the square root of an n line, and then we can have a, probably a integer. Most people enter integers, or if you want to do a floating point number, use a double. Probably doesn't matter, right? Some number to get root of, right? Sure. And again, your variable names can be really long because you don't have to type it, right? You hit a couple letters and Visual Studio types it for you. So use something long that is meaningful here. I mean, some number would work, but what is some number? I don't know. It's not that useful. And we can see in some number to get the root of. And then we can see out the square root of, and then we can add in the some number to get the root of. Let's go down the line is, and then we can use square root, and then in parentheses, we give it the some number to get the root of. We can add in that line. So it's called a function. That's a technical term. We'll get more into them later, but what you do is you put something inside of the parentheses. So functions will have parentheses, and we put something inside of it, and it does the thing for what you give it. So we could just give it 10 and say, hey, here's the square root of 10. It's more than happy with that, right? We could give it 42.5. It's perfectly happy with that, right? Or we give it a variable. Again, most of the time we're going to be working with variables because that makes our program more interesting. Because that way when we run it, we can give it different values. Or the person running our program, which is always you, right? Sometimes me. It's, eventually other people will use your programs, but you got a while till we get there, right? But with the user of your program could be anybody else. Sure. Can enter a different number. So it should work, right? It should be pretty good at figuring out square roots of things. We got to do a couple, 10 and 10 and 10. All right, what's the number to get a square root of? What should we get the square root of? 49. 7. Look at that. It does math. I know you're all impressed. So again, though, right, the common operators, right, plus, minus, multiply, divide, even modulus, there's no like key or symbol for square root that we can type. We don't have the little, what is the square root symbol? I don't even know what the term for that is. Is it just square root symbol? Okay, I wasn't sure if it had a fancy name or not. You can't type one of those on your keyboard very easily. Right? Technically you can if you care. A Unicode square root symbol. This is just a fun fact. You can get these things off your keyboard here with U221A for what it's worth. Right? You can get that character, but you don't want to have to type that in all the time. That's really obnoxious here in your code, right? You don't want to have to do that to get square roots, right? We can agree this is probably easy. Easier might be a stretch, but it's probably easier, right? Because it's used the regular keys. Okay. All right. Ooh, we should just add that in here, right? Because that'll look really fancy. Uh-oh. Some Unicode characters in this file cannot be saved on the current code page. We should resave this file as Unicode in order to maintain your data. Oh. No, that's lame. So these special characters are not regular characters, and they have to get saved special. So let's just not bother, because it would be special and lots of extra work. All right, so fun math things. I think that's about it for math things. Lots of other fun things. Look at that, the distance formula. We can calculate the distance between 2 points in math or in C++. Right, I'm sure you're all impressed. Okay. Sorry, some of the basics are boring, I'm sorry. It just won't be very interesting. It's just fun that you can do it here. Converting between types here. So we've done integers and we've done doubles, essentially. So if you want to do some arithmetic here, so let's say here's the double is a result, we can say my first number and second number. First number times the second number. And C++ is perfectly happy with that because double is bigger than an integer times an integer. Right? There's enough room for it here. But if I were to say, hey, I want an int of some number, some other result. I'm using bad names here, I'm sorry. But this is my some number to get the root of times the first number or something. Now I have a double, and I'm multiplying by an integer. I'm going to save it as an integer. It's okay with that. But is it going to give me what I want? Am I going to get the right result out? No, because you probably wanted your decimal places here, right? And now I'm going to lose the decimal places. So you can do some bad things if you're not careful. And we don't want those bad things here. Right? So if we see out, oh goodness, how about this is first number times some number to get the root of is equal to some other result. Probably not going to get what we'd expect if we gave the some number to get the root of as a double. So 10, 10, 10. Okay, so if we did like 42.5, we can get the square root of that. And then 10 times 42.5. Okay, shoot. Well, that one actually worked. Because that 10 was a fine multiple of that. I'm going to use a different number here. 10, 10, 10. How about 33.33333333333? There we go. So now we see we lose the results here because that's an integer, right? That math doesn't actually check out here. We've lost some decimal places. But C++ is like, sure, you can do that. So we have to be aware of the types that we're using. Right? If we're using something that has a decimal place, you probably want to leave it in a value that has a decimal place. You don't have to, right? But you're going to lose stuff otherwise. So you just got to be careful with that. If you want to explicitly change things, you can use this static cast operator, which is such a pain to do, but you can. So usually, right, when we are dividing integers, right, we're going to get some weird values here. So we want to specifically say, hey, I want these things as doubles here. So we get double results. That's all. That's kind of boring. Yeah, so usually if we screw this up, right, we'll get different results if we're not careful. Because we're getting integers divided by integers. Right, did we do that integer divided by integer? I think, did we get a double result at one point? I think we did. All right, so that's different types, converting between them. No, not that one. We're doing pretty good. There's a lot here. Binary. Binary is the bits and bytes. Do we talk about bits and bytes and storing things? Okay, so everything in your computer is stored in binary. There's zeros and ones. In your memory, in your storage, all the different things, you have a bunch of these bits lined up together, and they're either on or they're off. So binary is just base 2 numbers. So if you're on or off, you're a 0. If you're off, you're a 1 if you're on. And Windows has this really cool calculator, which is nice. And if you change the mode to programmer, you can change to binary here, and then you can go to this option here is the bit toggling keypad. Real long path, but that's okay. So now I have 64 bits I can play with, and I can toggle them on and off, on and off, on and off. So the power, or the value of each bit is 2 to that to that index. So this is the 0th bit. If it's on, it's 2 to the 0. If it's off, it's 0. If this one's on, it's 2 to the 1. If it's off, it's 0. If this one's on, it's 2 to the 2. If it's off, it's 0. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, on and on and on and on. So the 7th bit here is going to be 128 in our regular notation system. 128. So, right, you get 1, 2, 4, 8, 16, 32, 64, 128. You just keep on doubling because it's powers of 2. Yay, math. I'm sure you're very excited. What that means here now is in a 4-bit number. Right? So when we talk about integers, we have 4 bits for every integer in C++. So, I'm sorry, 4 bytes. A byte is 8 bits because it's all based on powers of 2. So the most I can have, if I turn all of my bits on, is 255. So the highest value of a single byte is 255. The lowest value is 0. So you get 256 different possible values out of a single byte. Super interesting math. I'm sorry, this is kind of dull. Okay, so if I'm going to use 4 bytes of data to store an integer, right, the maximum number I can get is 2 to the 31. Right, so that's 2,147,483,648 is the maximum value we can get in one of these numbers here. Now, you're going to think for a second, hey, what if I turn them all on here? When we can go toggle them all because it's fun. So the max value is actually a little higher here. But remember, integers can be positive or negative. So in order to store whether or not a number is positive or negative, we need to take one of these bits that's on and off and keep it. Set it aside to say, hey, if it's on, it's negative, or if it's on, it's positive. I forget which one it is. I could really care less. It does not matter to me as a programmer. But so I have really 31 bits I can use to store the value of an integer, and then 1 bit of those 32 to say if it's positive or negative. This is why everything's done in binary. Excuse me. So when we deal with integers, we can only get so large of a number, right? This 2, can I copy that? I can copy that here. Okay, so let's say here's an int, a largest int is this here. Now, this looks really ugly here. I think, can we throw these in here? Doesn't let us. Shoot, C++ hates me. Other languages, you can put in better numbers, or separators. Can we not do that? Not C++ let you do that. Separator. What is it here? Digit separator. Single quotation mark. Ah, single quotation mark. There we go. So let's try that. The apostrophe. Hooray. That looks super weird, but you can see digit groupings this way. Totally optional. Right? But I think this is a little easier to read a little than without. Right? So this is the optional digit separator. Right? Now the downside is, because it's basically ignored by C++, you can do dumb things like put them in everywhere. And C++ is like, sure, I'm just going to ignore it because I will not read those if you give me a number. They're for people. So don't do ugly things like that. Okay? It's probably best not to. But this is nice. So I can see the largest integer. So we can see out the largest int in C++ is the largest int. Okay? Now, what do you think is going to happen when we do arithmetic with this? Let's have an int, largest int plus sum. Here's my largest int plus some number. How about some, or first number? We'll just add something to it. And then we can see out largest int plus something. And see what we get. Should we try it? What do you think is going to happen? You think an error? It's a good guess. So we'll just keep doing 10s here. 10, 10, 10, 10, 10. Oh, I forgot my separator here. 2147483647. 2147483647. Did I do the wrong thing? I did the wrong thing. Yep. I used the wrong variable. So this is my bad. When I copy paste things, I was still using largest int, and we didn't change largest int. We made a new integer. So when I outputted largest int, it was still largest int. That's my bad. And let's add an end line here to make that look a little prettier. So those things will happen to you all the time if you have the wrong variable name places. It's easy, right? I mean, we got a lot of variables as we go. All right, so let's try that again. So 10 and 10 and 10 and 10. All right, so we go from 2147483647 to negative 2147483639. We added 10 worth of bits here, but because we went over the maximum, we like wrapped back around. And now we're at the very negative value here, plus 9. I think we lost a bit somewhere in here, or 8. Oh, goodness, the math here doesn't make any sense. It doesn't have to. We did a bad thing, right? And C++ is like, sure, I know how to do that. Turns out one of the rockets actually crashed because of this sort of error. I forget which one. Oh no, the rocket didn't actually crash. In testing, it crashed. Right? I think it did. I think that was pretty recent here. Hang on. Rocket simulation crash overflow. I just read about it and I was like, oof. I think, was it this one here? I think it was, oh, this one's old though. Come on. Really? Oh, yeah, no, okay. Yeah, okay, so this is an old one here. 1996. This is before most of you were born, I think. I'm an old person now. I'm not used to that. Because they went over their value. So their odometer value is supposed to keep on going, and it did an integer overflow. It overflowed the maximum size of an integer. Turns out the rocket went too fast. And then it thought it wasn't going fast enough, because now it thinks it's going negative or something stupid, right? That sucks. That's real bad, right? To blow up a rocket doing that. This happened more recently too, I swear. This is still an old one, right? Yep, 96. I just read about a new one here. All right, it's not that important, but it's interesting to see. So sometimes being accurate really matters, and things blow up if you don't do it right. Which is a little scary, but it's okay. Right? We'll get there. We'll get there. And this is why we test things, right? So the latest thing that I read about, which made me feel better, is in the simulation of it, the simulation crashed. And they're like, why did my pretend rocket crash? And then they figured out they were doing dumb things in integers again. So sort of makes sense. All right. So if you don't want to overflow, right, we have to use something bigger than an int. Right? We just don't have it in this section here. Where did it go? It gave us something bigger, didn't it? Strings, int overflow, numeric data types. Here we go. The numeric data types. So integers are usually 16 bits. We can get long if you want a long value, which is 32 bits. Why is that the same number? I'm super confused. Okay, but if you use a long, you can get 9 centillion. Is that it? Billion, trillion, quadrillion, it's centillion, right? 9 centillion? I'll just say it very confidently and you'll assume I'm right. Is that how that works? Okay. I've never had to count that high, so sure, you can use very large numbers then because you're taking up more space. Right? If we go back to our calculator here, if you use more of these bits here, right, go figure. Can I just clear all those out? There we go. If we go up to, this is 2, 3, 4, 5, 6, 7, 8 bytes worth, right? You get to 9 centillion or so. Go figure. So if we're using double the amount of space here, that's why they call it a long. It's longer than an integer. You can store more numbers, again, because it's all power of 2 based, which is really cool. We just keep on doubling every time we add more bits, and double and double and double and double and add more bits and add more bits and add more bits. Are any of you interested in stocks or the stock market? I know you're probably all too poor to actually care, or not care. Sorry, that's the wrong term here. I'm being a little tongue-in-cheek. It might be insulting. I apologize. I might have gone too far. Yeah. Yep. Mm-hmm. Mm-hmm. Yeah, there's a lot of places let you do that, or code in sites will let you write code for your own trading algorithms. There's a guy who streams. I got to find his name who does that. Hmm? Sounds familiar. I don't know all the different ones. Yep. So the only downside is because computers are really fast, right, you have to be careful because it's going to do what you tell it to do. So if you tell it to do something dumb, you can lose money even faster than you can on your own. But again, that's just the cautionary tale. Yeah, so lots of people do that. Most of the large trading companies, I believe, are relatively, maybe not all, but a lot of them have some automated trading sort of things like that. It's all code based. At one point, it was a big story. I don't know if it's still true. This is years ago because I'm old now. The big trading firms were buying office space in New Jersey because it was very close to New York City. And if your data center was closer to the New York Stock Exchange, you could get your trade signal in like ever so slightly nanoseconds faster than you could from California, right? Because you have to send a signal from across the country or from across a river, right? So the physical distance still matters a little bit. So yeah, doing the automated trading is really interesting here. Lots of fun stuff to be done there for sure. But the New York Stock Exchange, this was a fun tip. Was it New York Stock Exchange max stock value? They have to change it for Warren Buffett. Here, where is it here? This isn't it. Stock value. Um, Hathaway. So this particular stock here, Berkshire Hathaway, Warren Buffett's company that he does, is I believe the most expensive stock on the stock market in the New York Stock Exchange. And the way that they store these values, because the New York Stock Exchange deals with fractional pennies, turns out doing arithmetic with floating point numbers is slower. There's more things the computer has to do. So they said, hey, I have a clever idea. I'll just use integers and I'll assume now I'm dealing with 10,000ths of our pennies. So I can do 4 decimal places worth if I just multiply, or when I'm actually showing the real value, if I divide by 10, 100,000, divide by 10,000, I can store these as integers here and really just store the 4 decimal places in my integer value. And this stock price got so high it was about to overflow on their exchange, and they had to change their code to support Berkshire Hathaway because he refuses to split his stock because he's just a weird old man. And you're allowed to do that when you're a crazy rich old man. You can do things like that and irritate people. So integer overflows still happen. That's the whole roundabout long story of that. They do happen, and you gotta be careful. So we can use longs, sure. So for floats, so the book will use floats a lot. I don't like floats. It's just I don't. I prefer doubles. So doubles use 64 bits, right, or 8 bytes worth, and can store a really, really, really big number here. I don't even know how big that is. 310 to the 308th, really big here. That's pretty cool. Pretty cool. And the way that it does it, if you continue on, eventually you'll probably take the 310 class. I don't remember what that one's called. Computer Organization and Architecture or something like that. You'll learn how these sorts of things are actually stored in binary because reasons. It's interesting. I've never found it useful, but again, I'm very biased to software engineering, and I don't care how all the stuff happens behind the scenes. I just want my program to run, and I'm spoiled. I'm glad people understand how this sort of stuff works and make processors for me, but I just have no interest in being an electrical engineer. Bless those folks. So, but you can store all sorts of cool things. Oh yeah, here you go. So the sine, the exponent, and the mantissa. That's a cool term. You should go home and tell everyone you learned about sine, exponents, and mantissas, and just see what they say. You'll look really smart, or they'll call you a nerd. So sure. So some value, some exponent, and some sine. Sure, we can store all this in a 32-bit floating point value. Pretty cool. So that gets us up to 10 to the 38 somehow, right? So I guess the exponent here, we could store at least 38 in here. Sure, that sounds reasonable. It's really interesting stuff, but at this point in your, like, I'm learning how to code, this is really dull. I'm sorry. So we're going to talk about it once, and you're going to forget it for a year and a half until you go take 310, and then you can remember it for another semester, and then you can get rid of it again. And then depending on what specialty field you go into, it may or may not matter to you. Like people who do embedded systems work, and like they work on really small systems, it's kind of important to use the right numbers of bits and bytes and be efficient here. If you work on desktop hardware or server hardware, like I've got gigs of memory in this thing, I don't really care. That's a little bit silly, but it's true. But then if you start scaling things up to millions and billions of times of operations here, the speed really does matter and efficiency really matters. So there's like the happy middle where most of us just don't care. The people who do lots and lots of really big things care. The people who do lots of really small things care. And the rest of us are like, doesn't matter. Okay. So that's the long story short. Cool. So strings. Strings are super cool, right? We've been dealing with string literals, right? We said like hello here. Turns out everything is stored as a character. So we looked real briefly, it was on the screen, you probably didn't see it, that chars or characters are stored as numbers, which probably makes sense if you take this binary path down the trail, that if everything gets stored in binary, the only thing I can put in binary is numbers. I can't put letters in binary, right? Because it's not a number. I can only put numbers there. So letters are represented by numbers. I mentioned that Unicode table. So if you look up Unicode table here, sure, this is probably it. Oh goodness, that's not what I wanted. Unicode characters, here we go. All of the characters can be represented by a decimal value. This is our Unicode here. So most of the characters we use, where'd they go? These are all the special ones here, right? I just want my letters. Where's my letter? Here we go. So now we start getting your common keyboard symbols. So there's a bunch of characters like end of text, the backspace, the line feed, the carriage return, which carriage returns are different from line feeds on some systems, and Unix does it one way and Windows does it another way, and it just drives me crazy, but sure. Why not? Then the actual characters we care about. So most of the things we do are stored as values between 32 and 126. Pretty much all the characters on our keyboard, on a standard American keyboard. Other languages have their own sorts of problems, but they can be supported in Unicode because Unicode was like, or someone finally figured out not everyone speaks English. Like we need to support other characters. So Unicode gets larger, like there's the Latin 1 supplement, there's a bunch of supplements you can add in all sorts of funny characters. You can do the registered trademark character, you can do all the different characters with accents, you can do other languages, like we'll get into fun stuff eventually, but for our purposes, I'm going to assume we're all doing English here. Is that a fair assumption? Okay, so we're going to deal with from 65 for capital A up to 122 for lowercase z. That's our numerical equivalent for the characters. And when you have a string of characters, which is why it's called a string, right? It's a bunch of characters strung together. I don't know, we've called them strings forever. It makes sense to me. It just sounds ridiculous if you tell other people, though. All it does is store the number. It stores a number, 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 stores a number. So we can get individual characters back out if you want using characters. So let's see in a string. Yeah, so we can actually get string input as well instead of numeric. So far we've only done numeric input. So if I want a string, I can say, hey, let me get a string value here called string. Generally, you want to include string. Sometimes it works without it. I don't really know the difference. I just always include it because that's what it says to do, and it works. Occasionally, you don't have it, and it works too. So that's okay. So let's go in here, and we'll include a string here. Oh, goodness. Really? Okay, that's fine. I can type that one. Include string. Now, you want to be careful. When you're doing these includes, it like comes up with suggestions here. I don't know if you saw that briefly. It was saying I can use string or string H. Don't use the H ones. We'll talk about that when we get there. But for now, don't use the H ones. They'll do weird things. Okay. So include string. So now I can say something like, let's see, put it down here. We'll have a string for first name. How about a string for last name? Notice these show up in a weird color. They're a little bit different here. Most of my types here will show up as this blue color here. A string is technically something different. We'll get into that later. It'll make more sense later, but it's a different thing, so it shows up as a different color. That's all. It's not wrong. It's just a little different here. We'll see out to your first name, and then line, and then I can see in my first name. And I can do the same with my last name. Again, I don't want to have to type it all. Last name, and then we can see in for last name. And then we can see out. So now that I have that as a variable, I can use it in all of these see outs here, because it's always nice when the computer talks to you by name. You feel like, hey, this computer really cares about me. I've got a relationship with this computer. Oh, that was supposed to be kind of a joke here. I don't know, like, okay, sure. Hi there. First name. And how are you today? And then line. And then I'm going to make another string for just trash here, and I'm going to see in trash. I don't care what they say, right? But I need to see in something so they can type and hit enter. Right? And then I can see out, oh, that's nice. And bye. We'll just pretend to be your conversational bot here, but we just ignore what they say. We don't have any ways to deal with it yet. But now we run that, we should be able to see, hi there, Eric, or whatever you type in for your first name. 10 and 10 and 10 and 10. All right, enter your first name, Eric, and your last name, Charneski. Hi there, Eric, how are you today? I'm tired. Oh, that's nice. Sure, I mean, it's what it is. We haven't done anything interesting yet here. So we just see in here for trash. Now, interesting things here, when we're doing cin in strings, you want to be a little careful here because weird stuff will happen. So let me show you here, 10, 10, 10, 10. Okay, so if I say Eric Charneski and I type it all in here, notice it skipped the prompt for enter your last name, but it still got hi there, Eric. So when you see in, it doesn't deal with spaces. So when it sees a space, it thinks you must be done typing your string because you'll only ask for a string, not an entire line. It gets a little weird here. So again, we can just say hi or something, doesn't really matter. Oh, that's nice. So every time you see in here, you want to be careful. See in with a string only goes to white space. So it'll take any characters it sees until it finds white space, which is either the enter key, which is considered white space, right? Going down the line is white space. The space bar is white space. The tab key is white space. Those sorts of just blanks, it will stop at and say, oh, here's my string. I'm done. So you can't get someone's first and last in a single prompt yet. We haven't got there yet. We will in a minute, right? So just be careful. And if they enter something with a space, then the next time you ask for something, it's already there waiting to go, and it will get read in, it'll get inputted without waiting for the user to type anything. That happens because that output screen, the little black box that we type in, it's standard input and standard output. Like there's a buffer, and when you hit enter, it goes into the buffer, and cin will grab things out of the buffer. But because I hit enter, my last name was still in the buffer. So when I went to go see in something, it's like, oh, there's something in the buffer already, I can read it. For what it's worth. So it's a little tricky to get first name and last name that way. So this is without white spaces, right? Because as soon as we see the white space, it stops. I think it's got, does it not have that? Yes, here we go. So if you want to get the white spaces here, you use getLine. So getLine is really funny looking, but it'll work here. So we can say, hey, I want to get the line here. When you use getLine is a function, so it's going to have some parentheses. Functions can have more than one thing given to it, so you have to use a comma to separate them. So with getLine, you're saying, hey, get the line from the cin, from the standard input, and then you comma separate. You say, well, where do you want to put the thing that you've typed? I want to put whatever I read out of the buffer in last name. So this is, hi there. Let's do this. So we'll say use getLine to read the entire input, including white space. So instead of C in trash, I can say get line. I want to get from the C in, and I want to put it in trash here. And I can say, oh, that's nice. Right now we've got all that input here. Right? We're not doing anything with it. We could output it here. We could do something with it, but it's fine. So it'll get the entire line. So generally, I prefer get line when I'm doing input with strings because I don't want things hanging that screw up my next input. So where get line will get the entire thing until they hit enter, including all the white space. That's usually what you want. Generally, you don't want 3 different inputs here off of one user typing one line. So sometimes it's nice if you're like, hey, we just enter in a bunch of different values and we can separate them all out, but that's relatively rare. Okay. Yeah. So don't mix them. It sort of gets a little silly here. So just be careful. All right, we're getting there. Let's see. Ooh, constants. Constants are great. I missed this one here. So if we're dealing with numbers that don't change, a constant value here, we've got a shortcut for it here. Yep, const. Okay, so in C++, we can create constants. So there's a relatively well-known constant. I think you guys are familiar with pi here. Now, I think there's pi in the library, C++ math pi. Is it pi underscore pi? M pi. So if you include the math h, you can get m pi. My goodness gracious. Why do we have to use these different math ones? I don't know why it's m pi. And we're going to pretend we didn't know that, because who cares, right? But it's out there, sure. If we want, we can make our own. So I can say, hey, I want a constant double for pi. Now, with constants, the naming convention to indicate in your code that it's a constant is all uppercase letters. Now, because it's all uppercase letters, you can't do the camel casing with your variable names and like have capital letters for the next word here. So if you want to separate words, you use the underscore character. That's the shift dash. So this is pi to 5 decimal places. We'll be very specific here. And we can assign it a value. So 3.14159, right? That sounds about right. It's about as far as I ever memorized pi. At one point I had it further, but I think this is what I'm down to now. And I think this is better than 22/7, right? I think that's less accurate. What's 22/7? Oh, I gotta go back to regular mode here. 22 divided by 7, 3.1, or, oh yeah, 22/7 like screws up after the hundredths place. That's no good, right? We would crash a rocket with this accuracy. Right? But 5 decimal places, obviously we're superior. Okay. Anyway, so you can make these constants here. What's nice about these is I don't have to repeat this number anytime I want to do calculations. Right? If I were going to say, hey, let's calculate the area of or diameter of a circle, no, circumference of a circle, right? We could see out, enter the diameter of your circle, and then line, sure. Right, and then we can see in, oh, we need a value for it, so let's have a double for diameter. We can see in the diameter. Oh goodness, I can't type. We'll just copy paste. And then we can see out the circumference. I can't spell either, I'm sorry, is, and then we can add the diameter times pi. My pi to 5 decimal places. Now what's great is I didn't have to type this number, right? And if I was going to do more arithmetic with more circles, every time you have to type a really long number increases the chance that you type it in wrong, right? And let's be honest, I type things wrong all the time. You guys are probably better typers than I am, but I typo things all the time. So I would prefer to have a constant here because then I get to use the name for it. Now pi is pretty recognizable here. But you might have other values that are constants that you might not know offhand what it meant here. Sure. So like their example, what do they have here for constants? They had speed of sound. Really? 761.207 miles per hour at sea level. I learned a thing today. I will forget this very soon, but that's very interesting, right? And then seconds per hour. Sure, I just don't have to do this arithmetic more than once. So I can use these values in the code, right, as constants. So that way I don't have to retype the value here, which is nice. Does that make sense? So there's a general rule of thumb is that if you have a number in your code, we like to call them magic numbers, because if it's just the number you're doing in arithmetic, it's sort of magic. Like, you don't really know what it's there for. Or you probably know what it's there for when you wrote the code. When you come back 10 minutes later, or you come back the next day, or someone else looks at it, they're gonna be like, what's this number? It's a magic number. So giving numbers a name as a constant here removes that magic, right? You're like, oh, I know exactly what it is because it has a name now, right? Again, the code that we write is really for people. Yes, it follows the rules so C++ can execute it, but the reason we write code is so that we can see what it is. Right? We want to be able to come back to it and understand it and read it later, because you want your code to be readable, right? So constants are a great way for that. And then the other thing, because it's marked as constant, I can't change it by mistake, right? If I just said, hey, here's a double for pi here, and I said 3.1415, right? If I wasn't careful here, I could say, hey, let's pi equals, I don't know, 5.2, 5.4, sure, and change it. Just because, hey, I probably copy pasted the wrong, I meant to say diameter or something here, but I used the wrong variable because I wasn't paying enough attention. You can change the values. When you mark something as constant, once it's been given a value, you can't change it here. Like, I can't say 10.5 here. Now I get a big fat red line. It says expression must be a modifiable L value, which is a garbage error here, but must be modifiable. You can't change this value here because it's constant. Not the most helpful error, but at least it won't even run now. Like, I can't even hit run because it's just going to fail on me here. Again, never click yes. Yes is never the option you want here. When you get this, there were build errors, would like to continue to run the last successful build, always say no. Because if you say yes, it's going to ignore what you just did and give you last version, which is not helpful because you want it to run the code that you typed, right? So don't ever hit yes to that. Yeah. I'm pretty sure if you hit the checkbox, you don't have to. I'm scared that it'll just run the program anyway, and I like that it prompts so that I can warn everybody every time. And I'll deal with a little bit of annoyingness because it's nice that sometimes I miss the errors down here because I'm not paying enough attention here. So here we go. Now we get a better error. Now it's saying, hey, pi to 5 decimal places, you cannot assign to a variable that is const. Now we finally get something nicer. Like, that makes much more sense than a modifiable L value. That's just garbage. So we can say can't change. Can't change constant values. Right, so that's the other reason we use a constant, right? It's safer. We're not going to accidentally do something here. All right. Awesome. We are almost done. You guys are doing great. Doing great. And let's see, strings, numeric types. Unsigned, the idea of I'm unsigned, so I don't have negative. There's no sign for positive or negative. I'm only ever positive. If you want an unsigned int, you can get to the 4 billion mark because you don't need the negative 2 billion sum. Sure. Again, fancy tricks. We generally don't care. It's a lot of effort to have to think about these sorts of things. Be like, okay, this one is unsigned, this one is signed, this is a regular int, this is not. And I just don't care most of the time. But you can. So you might see some weird stuff like that. Hey, this is an unsigned something. Go for it. They're fun. Random numbers. Random numbers are really cool because doing things that look like they're different every time, look like they're random, is much more interesting. So we can make our programs behave differently every time they run because we can use these random numbers. Now, I obviously need to caveat this. It's not actually random because there's a computer program that says do this thing and do this thing and do this thing and do this thing to generate a number. It's pseudo-random. It looks like it's random. It's random enough for us. Don't use this for anything that matters cryptographically, and don't use this for a casino. People lost money. A slot machine operator lost a bunch of money because they were using a random number generator on the display of their slot machine. And I think it was a Russian hacking group figured out they could use a camera in their shirt pocket to record it and then predict when to hit the stop button to get a jackpot, because it was using the same random number generator to do the scrolling sequence as it did to get the actual end results here, and they were able to make money. Now, the funny story, the casino realized this was happening because they were losing money on the slot machines. That never happens, right? Slot machines don't lose money. Why else would a casino have them if they lost the money, right? So they're like, hey, why are we losing money on our slot machines? And they found that this was happening. There's an interesting story here. I think it was Russian slot machine hack. Is that it? Yeah, this one. Okay, so this is from 2017. Yeah, this is, sure. Okay, that's a fun article. Just if you want to go look that up later. It's okay. That's a rabbit trail. Sorry. So random number generator. We can make random numbers. So to do that, you say rand, and it gives you a number between 0 and the random max. Sure, we like that. Depending on your machine, rand max is different, which is super weird. But okay, sure, why not? Generally, it's probably about the top of an integer for most machines. I don't think any of our computers nowadays have the low max for rand. I don't know that for sure, but I would assume they all have the high one. So most of the time, we don't want a number that large, though. If I want to say, hey, I want a number between 1 and 10, right? So let's say, well, we'll do this as it. So int number 1 to 10 is rand. So if I get a random number, and it's between 0 and max here, to limit it down to what number is 1 to 10, I want to take modulus 10. That will divide by 10 and give me the remainder. Now, I'm going to get 0 to 9 here at this point, so after that I want to add 1. So if I get 0 to 9 and I add 1, I now have 1 to 10. Right? So random number modulus the max value plus 1 will get you 1 to that value. I think that's some straightforward arithmetic. If you want a random number 10 to 20, right? Well, I need X numbers of values in the range. I think that's 11, right? 11 values in the range. So I would want to do modulus 11, and then I would want to add 10, right? Okay, let me leave this here. So int number 10 to 20 is rand modulus 11 plus 10, right? So always add your minimum, right? And you're modulusing by the max range. Or if you want to be do this a little easier here, right, you can have a min value is 10, and then we can have the max value is 20, right? And then we can mod by my max value minus the min value plus 1. We always have to do plus 1? I feel like we have to do plus 1. If I have 1 to 10, yeah, I think we always have to add the 1 here. Right? So this way I get the full range here. Does that make sense? So this is fun and all, but what if we ask the user for those? Right? Why not? Let's ask the user. So this is a random number. So I'll leave this one here. I'll just move this one up here. And then we'll just say here's min and here's max. And then I want to add in the min after not 10. There we go. Add in the min. Okay. So we can see out, enter the minimum random value. And then we can see in for min value. Oh, I got to do the up here. I can see in my min value, and we'll do the same for max. For the max value, some random value, and see in for max value. And it probably is going to work here, right? This is just my random number. Right, so pick a random number, modulus by the range of values, and then add in the min value. Give it a try. 10, 10, 10. Eric Tresky. Uh-oh, we lost the other one. That's weird. Diameter of our circle, sure. All right, and what's the minimum random value? What should we try? 10? All right, what's the max random value? 32? We didn't output our random value. Oh, that's sad. See out. Your lucky number is, and a number. All right. It's having all this other example stuff at the top is annoying. Sorry. 10, 10, 10. Eric Shanesky. Uh-oh. When I mixed my get line and my CINs, I got some weird stuff. It never even got that how you today prompt because I got the line there. You gotta be careful with them. So generally you'll do like a blank one of those and then you can do another one if you're mixing and matching. Just don't mix and match. Okay, so diameter of the circle. All right, minimum random value 10, max is 32. Our lucky number is 31. That's between 10 and 32. We did it. That's kind of annoying to have to run that every time to see our random numbers, right? But that's fine. How about let's do this. Let's do this 6 times for someone, and or 5 times we can generate a lottery ticket for them. That's fine. We can just copy paste it a bunch. You're just as likely to win, right? Picking a random number as you are picking your own numbers. Math works like that, I'm pretty sure. So, all right. We're almost out of time. I think we got all the stuff here, so we got to talk about the project. Let's see, we get to all of it. Auto is really cool. Style guidelines. I don't care much about style. Other people are very particular about style. Sure. Really, whoever signs your paycheck, just go with it. Go with that style. Whoever's grading your work, go with that style. For debugging, this one's worth it here. It's not super useful for us for now, but next chapter, it'll be very useful. So I'll save showing that to next chapter because we got to talk about the project. But you can debug. You can come over to this gray space here and just drop a big red dot. That's called a breakpoint. And then when I run my program, it will pause for me, which is really fun. 10, 10. Eric Shanesky, diameter of our circle is 10. And it pauses here. It says, hey, this is the line I'm about to run, and you can see behind the scenes, these are all the values my program has. It has min value, it has max value, it has some number, it has other number results, it has first name. So you can see what's happening behind the scenes, and then you can run code line by line by line. So these buttons up here now are my debug tools. I will step over the little loopy arrow, so steps, it does one line at a time of commands. Now it gets a little funny here, because it looks like it's not running anything, but it's sitting waiting for the CIN here for the min value. So I can give it the min value, and now it comes back and say, okay, now I'm ready to run this line. So just dealing with input and output gets a little weird because it like pauses, but it's fantastic. And you can actually see the values. So you can see here that my trash is just an empty string. You're like, hey, why didn't it prompt anything? Like, oh, it just got an empty string. That's all. So debugging is really helpful. All right, so let me go back to Canvas here, and we'll go to assignments. I didn't make the classroom link. Shoot. All right, I got to do this real fast to get you a link here. We'll show you how this works. Let's do this one. This is CIS150, fall 2023. So we would have done this for our first lab. We'll do it on Monday. We'll practice this process here, and it'll make a little more sense for you. So don't sweat it here if this doesn't make a lot of sense yet. So you don't have to follow this workflow yet. You can just practice on your own program, and I'll show you how all this works here in a little bit. 150, fall 2023. This is project 0. C++ template. I think that's it. There we go. This way you get a private repository that you have access to, and I get access to it as well. And then no one else has access to it. Life works out pretty well here. So let's make project 0. 0. Submit the URL to your repository. Again, we'll get to that later. Don't worry about it. So we're going to submit a website URL. Canvas is pretty handy there. We'll call this worth 10 points. Okay, so we're going to write a program that helps us plan a party. Right. So we're going to have a party. It's a little bit after Labor Day. I'm sure there's some reason we can have a party in September, later in September, right? Sure, for a Friday. We'll have just a fun Friday party. So a couple things we're going to need is next chapter is dealing with, depending on what the user enters, we'll do different things. Again, we can get to that part after here. So we're going to ask the user what sort of food they want to have. And we're only going to take 3 different inputs here. And if they don't give us one of those 3, we're just going to ignore them. Again, we'll get to that next chapter. So this part can wait until next week. So their choices are What do you think? Pizza. What else do you like usually have at parties? If it's not pizza, you might serve sandwiches. Sure. If it's not pizza or sandwiches, you might serve drinks. Sure, just drinks. Okay, cool. So if they are serving pizza, after that. So then ask how many guests are expected, right? So we know how many guests they expect to have. And then if they are serving pizza, ask how many slices the average guest will eat. So, hey, I'm going to have 10 people over and most of my friends eat 3 slices of pizza. So pretty quick in our head, we're like, hey, we need 30 slices of pizza. But again, we'll make the computer do this sort of work for us, right? All right. Ask how many slices the average guest will eat. Ask how many slices each pizza has, right? If you order mediums, you get 8. If you order larges, you might get 10. If you order like those real big deep dish full Jets pizzas, you might get 12. I don't like, sure, you just tell me how many slices your pizza has, right? And then we will calculate how many whole pizzas are required to feed the guests, right? We're doing that arithmetic. So to do that, right, we need to make sure we get the right number of pizzas. Don't tell me to order 3.5 pizzas. I need 4, right? Whole pizzas I'm going to order, right? Not 3.5, right? So we'll have to do some rounding or do some checking here. Hey, is there a remainder? Or got some options here, okay? All right, if we are, oh, and we're also going to ask how much each pizza costs and print the total expected cost for the party. Right? Hey, if each pizza costs $10, if I'm going to need to buy 5 pizzas, then hey, it'll cost $50. Right? We'll do some arithmetic there. Just practicing some of these things we've done. It's nothing super crazy. Okay. If we are serving sandwiches, I can never spell sandwiches. Ask the user how much meat each average guest will eat. Hey, the average guest eats half a pound of sliced turkey. I don't know. Sure, 0.5. You can make it up, right? Or my son eats lunch meat like you would not believe, but he's 15 and he eats more food than I do. Or eats more than I do. Yeah, okay, that's good English. Okay, so then we will calculate how many whole pounds, not 3.5 again, of sliced meat you need to buy. Ask the cost per pound of the meat and print the total expected cost for the party. You get the idea here. It's real similar here, right? Now we have sandwiches instead of pizzas, okay? And if they are serving drinks, the user, how many drinks the average guest will drink. I think that's right. How many drinks you'll drink or drinks you'll consume. Is consume a better word there? Consume sounds fancier here, right? Okay, and then calculate. Maybe not how many average drinks. How many? What ounces? Do we measure things in ounces or milliliters? Ounces. Okay, how many ounces? Ounces. The average guest will consume, and then calculate how many fifths or that's in milliliters too, isn't it? Calculate how many gallons, right? Whole gallons of drinks, not 3.5, you will need to buy. And then ask the cost per gallon and print the total expected cost for the party. All right, so 3 different ways this could go, but essentially we're doing the same thing for each of them, right? With what's the average, get a whole number, right? Based on that, whatever it happened to be, and then the cost. Right, so we're just trying a couple things here, doing some basic arithmetic with different options. What we're doing here, okay? That sound okay? Then after that, though, after that, ask the user how many guests actually came to the party and calculate like the remainder of Slices, what do we have? Pounds? How much meat eat in pounds? Slices, pounds, gallons. And output what is left. So, hey, I planned for 10, 8 people actually showed up. This is how much leftovers I have. Hey, I planned for 10, 12 people showed up. I have no leftovers, right? Or maybe you do, right? If we're buying whole pizzas and it just happened to work out that you had, like, you needed 31 slices or something like that. Or no, 33 slices and you bought a bunch of 8-slice pizzas. We had 40 slices and 2 extra people showed up. There was enough pizza, right? So sure, it'll be okay, right? Output what's left based on averages and actual attendance. There we go. Does that make sense what we're going to do? So again, you don't have to do the whole part of it yet, right? It's okay. We'll get to how we do just one of these 3 things. But aside from that, we can do the rest of it now. Right? If you just want to tackle pizza now, you can do pizza now. If you just want to tackle something, like, we can do those ones now, right? And then we're also, so we're going to submit the URL to the repository, and we're going to include screenshots in the README of the program running. Okay, and I'll show you how to do that in lab. I did one screenshot for you. I'll show you what we're going to do there, okay? And then I'll build a rubric out for you later, and it's 12:15 right now, so we got to go. Next week, I'll show you the rubrics, like you get 2 points for doing this, 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 okay? All right. Awesome. I'll see you folks on Monday. So we'll do class and then lab. No, lab's only on Monday. Yep. Hi.
Guess you can disregard it because my and we were supposed to meet in April.
I saw that. So I'm going off of what was on the PDF. I have to ask my department if we need to move, and I hope they say no because this room's much nicer.
Okay,
than the
because I was
NSB.
sitting there for like.
I'm
40 minutes,
sorry.
and I was like, but I didn't get the syllabus until I opened up Canvas.
Oh
because I was
yeah,
having
yeah,
issues
it's in
with
Canvas. I'm sorry about that. So, oh, I gotta stop recording actually.